Difference between distance and displacement. Let us understand the difference between distance and displacement with the help of an illustration. Here you can see an athlete running along a circular track of radius r in a clockwise direction. He starts from the point A and finishes at the same point. What is the distance covered by the athlete? The distance covered by the athlete is equal to the circumference of the track, which is 2 pi r. Is there any displacement or change in position when the athlete comes back to A? No, there is no change in the position of the athlete because the final and initial positions of the athlete are the same. That is, the displacement is equal to 0. Now let us calculate the distance covered and the displacement if the athlete stops at point B, which is diametrically opposite to the point A. The distance covered by him would be equal to half the circumference of the circle, and the displacement being the shortest distance between the initial and the final positions of the athlete is equal to the diameter of the circle. Thus we can define the distance covered by a moving body as the actual length of the path covered by the moving body irrespective of the direction in which it moves. And displacement can be defined as the shortest distance between the initial position and the final position of the moving body. Displacement can also be defined as the distance covered in a particular direction. Distance and displacement, an activity. Distance is the actual length of the path covered by a moving body irrespective of the direction in which it moves. Displacement is the shortest distance between the initial position and the final position of the moving body. Now try solving numericals on distance and displacement. Each question will appear on the screen one by one. Gain the appropriate answer. Jack starts from his house and travels 12 meters towards east and then 5 meters towards north. Find the displacement and distance covered. Anita travels 4 meters towards north, 3 meters towards east, and then 7 meters towards south. Find the displacement and also the distance covered by Anita. Displayed on the screen are a few line diagrams representing the motion of an object. The arrows indicate the direction of motion. Click on the appropriate option.
Uniform speed and non-uniform speed. Observe the motion of the car displayed here. We observe that the car is covering a distance of 10 meters in every 1 second. That is, the car is moving with uniform speed. Thus, if a body covers equal distances in equal intervals of time, irrespective of direction of motion, then it is said to be moving with uniform speed. In other words, the body is undergoing uniform motion. When a body moves with uniform speed, then the total distance traveled by the body in a certain time interval is given by the relationship distance traveled is equal to uniform speed into time interval, or S is equal to V into T, where S is the distance traveled, V is the uniform speed, and T is the time taken. The movements of the planets around the Sun is uniform motion. Non-uniform speed. Observe the motion of the car displayed here. We observe that the car is covering unequal distances in equal intervals of time. That is, the car is moving with non-uniform speed, or it is undergoing non-uniform motion. Now observe the rubber ball that is dropped from a certain height. When the ball is dropped from a height onto the floor, it bounces off to a certain height. In subsequent bounces, the height keeps on decreasing. Here the ball does not cover equal distances in equal intervals of time. That is, the ball is moving with non-uniform speed. Thus, if a body covers unequal distances in equal intervals of time, or equal distances in unequal intervals of time, irrespective of direction of motion, then the body is said to be moving with non-uniform speed. When a body travels with non-uniform speed, then the average speed of the body is given by the formula average speed is equal to total distance traveled by total time taken. Different types of motion. Here is an activity on different types of motion. Observe the motion of the displayed object and click on the type of motion and its definition.
ST graph or distance time graph. Let us learn to plot a distance time graph for the given data and to calculate the corresponding physical quantity from the graph. Draw two straight lines, one in the horizontal direction and other in vertical direction from the left-hand side bottom corner of the graph paper. The horizontal line is called x-axis and the vertical line is called y-axis. The point of intersection of x and y-axis is called origin. Plot the independent variable on the x-axis and the dependent variable on the y-axis. That is, plot time on the x-axis and distance covered on the y-axis. Analyze the given data and choose a proper scale, such that the whole range of variations are well spread out on the whole graph paper. Plot the points with crosses or with dots and encircle each of the points by a small circle. Join the plotted points to get a best fit graph. Give a title for the graph. Consider any 2 points A, B on the straight line graph. Draw perpendiculars from A and B to X and Y axis and construct a right-angled triangle ABC. Find the slope of the straight line graph. The slope gives the speed. That is, the physical quantity that we obtain from a ST graph is speed. VT graph or velocity time graph. Let us learn to plot a velocity time graph for the given data and to calculate the corresponding physical quantity from the graph. Draw 2 straight lines, one in the horizontal direction and the other in vertical direction from the left-hand side bottom corner of the graph paper. The horizontal line is called x-axis and the vertical line is called y-axis. The point of intersection of x-axis and y-axis is called origin. Plot the independent variable on the x-axis and the dependent variable on the y-axis. That is, plot time on the x-axis and velocity on the y-axis. Analyze the given data and choose a proper scale such that the whole range of variations are well spread out on the whole graph paper. Plot the points with crosses or with dots and encircle each of the points with a small circle. Join the plotted points to get a best fit graph. Give a title for the graph. Consider any 2 points A, B on the straight line graph. Draw perpendiculars from A and B to X and Y axis and construct a right-angled triangle ABC. Find the slope of the straight line graph. The slope gives the acceleration. That is, the physical quantity that we obtain from a VT graph is acceleration.
Speed time graph. The speed time graph representing the motion of an object can be used to calculate the distance covered by it. Let us now see how speed time graph can be used to calculate the distance covered by a moving object. A car starting from rest accelerates to a speed of 30 meters per second in 10 seconds and then decelerates for 20 seconds and stops. Draw a speed time graph to represent the motion of the car and use the graph to calculate the distance traveled by the car before it comes to rest. Draw X and Y axis as shown here. drag and drop velocity and time on the appropriate axis. The car accelerates to a speed of 30 meters per second in 10 seconds. Identify the graph representing the motion of the car by clicking on the appropriate graph. The car decelerates for 20 seconds before coming to rest. Identify the graph representing the motion of the car by clicking on the appropriate graph. Distance covered by the car is equal to Distance covered by the car is equal to area of triangle ABC Area of triangle ABC is equal to half BH. Now let us calculate the area of triangle ABC. Area of triangle ABC is equal to half AC into BD. Base is equal to AC is equal to 30. Height is equal to BD is equal to 30. Area of triangle ABC is equal to half into 30 into 30. Therefore, distance covered by the car is equal to 450 meters.
Identification of graphs. Here is an exercise on different types of graphs. A set of graphs will appear on the screen. Read the question and click on the appropriate graph. If you need help, click on the button provided. Identify the graph that represents a body at rest. Identify the velocity time graph representing uniform retardation. Slope of one of the graphs displayed here gives acceleration. Identify the graph by clicking on the appropriate graph. Identify the graph representing the motion of a body with uniform speed. Identify the graph representing the motion of a body with uniform speed. Interpreting graphs. Distance time graph. A distance time graph tells us how far and fast an object has moved with time. Displayed here are the distance time graphs. Click on each graph to know more. The straight line graph indicates that the object is moving with uniform speed. Steeper the graph, faster the motion. The slope of the graph gives the speed of the object. The distance time graph shown here denotes the motion of an object that moves initially with uniform speed, is stationary for some time, and then finally comes to rest. The curved graph denotes the motion of an object moving with variable speed. Speed-time graph. Let us now analyze a speed-time graph. A speed-time graph tells us how the speed of a moving object changes with time. Slope of the speed-time graph gives us the acceleration. Straight line graph AB indicates that the speed is increasing with time. Steeper the graph, greater the acceleration. The horizontal line BC shows that the object is moving with uniform speed. CD indicates that the speed is varying. The downward sloping line DE indicates that the object is slowing down. Here is an activity on graphs. The distance time graph shown here represents the motion of 3 athletes. Identify the winner by clicking on the appropriate graph representing the motion. Identify the athlete who stopped for rest by clicking on the appropriate option. For how long did athlete C take rest? How long did athlete B take to complete the race? What is athlete A's average speed? Speed time graph and acceleration. Let us now solve an activity on speed time graph. The speed time graph shows how the speed of a bus changes with time. Observe the highlighted part of the graph and click on the appropriate word used to describe the motion during each part of the journey. During which part of the journey was the bus moving with a maximum speed? During which part of the journey did the bus have maximum acceleration? What is the acceleration between D and E?